So our first sensor is strain gauge sensor. So this is strain gauge or pressure sensor. So what is the principle of strain gauge or pressure sensor? Gauge is nothing but a wire. So when we are applying pressure on gauge, it causes strain. So what is the principle of strain gauge sensor? If a metal conductor is stretched or compressed, its resistance changes on account of the fact that both length and diameter of the conductor change. There is a change in the value of resistivity of the conductor when it is strained, and this property is called piezoresistive effect. Come to this diagram. So this is a conductor. This conductor is stretched by using some pressure, nothing but some force. So this conductor is stretched using some pressure or force. So initially the length of the conductor is L and the diameter of the conductor is D. So this is the length of the conductor and this is the diameter of the conductor. If it is stretched, both the length and diameter changes. If it is stretched or compressed, its length and diameter of the conductor changes. The length is increased by delta L and the diameter is decreased by delta D. Here the length of the conductor is increased by delta L and the diameter of the conductor is decreased by delta D. So when the length and the diameter changes, the resistance of the conductor is also changes. So this is the principle behind the strain gauge sensor. So what is the principle? When the conductor is stretched or compressed, both the length and diameter of the conductor changes. On account of that, the resistance of the conductor is also changes. By estimating the resistance, we can estimate how the gauge is caused by strain. So that is the principle. So by estimating the resistance, we can estimate the strain produced in the conductor or gauges. So this is the principle of strain gauge sensor. Come to piezoresistive effect. What is meant by piezoresistive effect means when the material caused strain, that means piezo means squeezing. So when squeezing takes place, its resistance changes. So that is called piezoresistive effect. Here also, when the material undergoes either compress or stretching, that means squeezing, its resistance is changes. So that's why this effect is called piezoresistive effect. Okay, clear? So go to this definition. A strain gauge is an example of passive transducer. Already we discussed what is meant by passive transducer. So here the strain gauge is an example of passive transducer which converts mechanical displacement into a change in resistance. So this is a gauge, nothing but a thin wire. When stress applied on the gauge, the length and diameter of the gauge changes. That means mechanical displacement is produced. With respect to this mechanical displacement, the resistance of the gauge is also changes. That is the principle. So the strain gauge is a thin wafer-like device that can be attached to variety of materials to measure the applied strain. So if the applied strain changes, the resistance of the wire changes. By estimating the resistance, we can estimate the applied strain using these gauges. Okay, clear? So this is a foil type gauge. A series of resistors are arranged or mounted on a backing material is called a foil type gauge. So here also, in this type of gauge also, when it is subjected to stress, the resistance of the foil changes in a definite way. So the resistance which is changed that can be estimated using a Wheatstone bridge. So the strain gauge is connected to a Wheatstone bridge circuit. The change in resistance, this is the working principle. The change in resistance is proportional to the applied strain. The change in resistance is proportional to the applied strain, and it is measured with the Wheatstone bridge. So come to this diagram. Wheatstone bridge is nothing but it consisting of 4 arms. 1, 2, 3, 4. So along the 4th arm we are connected a gauge. Okay, clear? So when stress applied on gauge, strain produced, due to the strain the resistance of the gauge is changes. Okay, clear? So initially in Wheatstone bridge, when we connected resistors, if the bridge is in balanced condition, the current flowing inside the bridge equals to 0. That means when R1 by R2 is equals to R3 by R4, that is the balancing condition. At that time the current in the bridge is equals to 0. When any change in the resistor of any one of the arm, then I is not equals to 0. That means bridge is in unbalanced condition. When no strain produced in the gauge, then the bridge is in balancing condition. When any strain produced in the gauge, then the resistance of this wire is changes, gauge is changes, which causes unbalanced condition in the Wheatstone bridge. And using the balanced condition of Wheatstone bridge, we can estimate the resistance in the 4th arm. By estimating the resistance in the 4th arm, we can estimate the produced strain in the gauge. So this is the principle. Okay, clear? And one more parameter, that is nothing but sensitivity of strain gauge. It is described using a gauge factor. So what is gauge factor means? The fractional change in the resistance to change in length. Delta R by R by delta L by L. This ratio is called gauge factor, which is called sensitivity of strain gauge sensor. And this gauge factor is also related to Poisson ratio, which is mu. Poisson ratio is called, this is the ratio of lateral strain produced to longitudinal strain. That ratio is called Poisson's ratio. Here the gauge factor K equals to 1 plus 2 mu. So these are the types of strain gauge sensors. Based on principle of working, these are classified into mechanical, electrical, piezoelectric. Based on mounting, bonded strain gauge, unbonded strain gauge. Based on types, foil strain gauge, semiconductor strain gauge, photoelectric strain gauge. Advantages and disadvantages. Advantages. There is no moving part in the strain gauge sensor. It is small and inexpensive. Come to disadvantages. It is a non-linear. The output which is coming from the strain gauge is a non-linear output. It needs to be calibrated. Applications. So these are used in so many applications. To estimate the residual stress. It is used in vibration measurement and torque measurement, bending and deflection measurement, compression and tension measurement, and it is used in strain measurement. Here we are measuring the strain.